Differential equations, session 3. See, in this session we are going to discuss on two subtopics, that is geometrical interpretation of pdx plus qdy plus rdz, and also the methods of solving pdx plus qdy plus rdz. In this, three types of methods are there. Let's see how many methods we are able to solve in this session. First, let us take this geometrical interpretation of pdx plus qdy plus rdz. Now for this, let us consider the surface f of x, y, z is equal to constant or C. If I consider this surface, I know the partial differentiation of this is what? Dou f by dou x, dou f by dou y, and dou f by dou z. This is actually proportional to the direction cosines of the normal at x, y, z on the surface. It is proportional to this direction cosines of the normal at this surface. But what do we know? Dou f by dou x into dx plus dou f by dou y into dy plus dou f by dou z into dz is equal to 0. When I compare this with our total differential equations, comparing, what do I get? P dx plus q dy plus r dz is equal to 0. Now you can see here that dou f by dou x, dou f by dou y, and dou f by dou z is proportional to what? P, q, and r respectively. So if I consider geometrical interpretation of this is equal to 0 as equation 1, then the equation 1, actually this one, represents the infinite system of surfaces. It has got within it infinite system of surfaces, so that the direction cosines of the normals at any point, if I consider at x, y, z on a surface belonging to this system, are also proportional to the value of, since this is proportional to the normal DC, direction cosines of normal, it is proportional to this. And we know this is again proportional to PQR, and hence we can say that direction cosines are directly proportional to my PQR. So that infinite system of surfaces will be there in this surface, that is pdx plus qdy plus rdz is equal to 0. In this equation we are able to find. This is our geometrical interpretation of the system. Now, before going to the method of solving pdx plus qdy plus rdz, let me tell you one note. The integrability condition we have learnt in the session 2. The easy way of writing that formula, I will teach you how to write. See, let us write the determinant PQR. Then let me write dou by dou x, dou by dou y, and dou by dou z is equal to 0. Now expand this determinant. We will get back our integral, that is P into cross multiplication. Leave these two. So you get dou q by dou z minus dou r by dou y minus q into dou p by dou z minus dou r by dou x plus r into dou p by cross multiplying, leaving this column and row where r is there. You know this determinant, how to do this. Dou p by dou y minus dou q by dou x is equal to 0. This is the integrability condition that we will be able to write this with this method. So now let us go to the second part, that is the method of solving pdx plus qdy. The second part is methods of solving pdx plus qdy plus rdz is equal to 0. There are three methods in this. Let me name each one of them. See, method 1 is called solution by inspection. By seeing that, we will be able to find the solution. That means we are able to guess what solution can be there. Second one is one variable. You are considering it as one variable is considered constant here. If we have three variables, we consider one variable as constant. Two variable, we consider one variable as constant. And the method 3 is homogeneous equations. These are the three methods are there. Now let me take the first method, method 1. That is what? Solution by inspection. Now before going to this method, let me tell you about this method. This is actually rearranging the terms of the given equation. Whatever the equation you have, you are arranging that equation, or by dividing by a suitable functions of x, y, z, or by both. Then the equation may be altered. Here you can alter the equation, and which contains several parts which are your exact differentials. So let us see the solution by inspection. So take the first one. For example, x dy plus y dx. Now by seeing this, we can able to tell this is a product rule that has been applied. First function into differential of second function into differential of first function. So by the, what is it? The backwards differentiation or backward form, if we take it, is differentiation of xy, differentiation of two variables. We are able to write like this. This is by inspection. By seeing this, I am able to write in this form. Similarly, if I take this, for example, 2x square y dy minus 2x y square dx divided by x to the power 4. Now this, what type of a differentiation this can be? This is a quotient rule. You know it is a quotient rule. And denominator we have x to the power 4 means denominator it is x square only. Right? Denominator can be x square. When we look at the numerator, the first function x square is as it is. Differentiation of the second function y square is 2y into dy. Here the differential of the second function, first function, that is the denominator function, is x square is 2x, and second function y square is as it is. So it should be y square here. So we are able to inspect that it is differentiation of quotient rule y square by x square. So we are able to write this. Now similarly, let us consider the third one. We have xy dz plus xz dy plus yz dx. Now what is this? It is again product rule with three variables in it. So two functions, differentiation of one function, keeping two constant. Here also we are keeping two constant and differentiation of one function. Here also in the same way. So it is differentiation of three functions, that is x, y and z. Next, if we consider the fourth one, for example, solve 2yz dx plus zx dy minus xy into 1 plus z dz is equal to 0. Now here we can see that there is no variable of x, but we have dx here. No variable of y, we have dy here. And here what do we have? X, y, 1 plus z dz. So here we have z term also. So what we can do is, we can divide throughout by x, y, z here in all the three terms. So if I divide by x, y, z, I am going to have yz gets cancelled, and I have dx by x only plus dy by y minus 1 plus 1 by z dz is equal to 0. So where you had many variables with it, we made it with a single variable, that is with respect to whatever the differential is there, the same independent variable we are having in the, so it is easy to integrate now. So by inspection we are able to find out whether what we have to divide with. So we are able to follow this method. Now on integration, if I integrate this, what do I get? If I integrate this, 2 times integration of dx by x is log x plus log y minus of integration of dz, each function dz will be z, plus integration of 1 by z is log z is equal to 0. Now everywhere we have log function, and we can take this is equal to integrating constant also, we can write log c. After integration, let me write the integration constant. Now this will be what? Log of x square. See, we have 2 here. We have used the logarithmic formula like log of x square plus log y plus log z. Let me take that log c to the other side. It becomes my